Solve the following system of nonlinear equations algebraically. So it's not really all that necessary to know what types of equations these are, but it might be helpful to visualize the number of solutions that are possible. Because every time we have an intersection between two curves, we have a solution to the system of equations. In this particular case, the first equation is a circle, and I think that you all should know that at this point in the course because we've studied circles at this to now. But the next one is a different type of equation that you probably haven't seen so far. This is called a hyperbola, and a hyperbola looks something like this. It may not be going up and down, it may be going left and right. It sort of depends on some other factors, but it's kind of like this, and there's some asymptotes that guide it to infinity, but it sort of looks like two parabolas on top of one another. But again, you don't necessarily need to know that. But if you did, and you knew the other one was a circle centered at the origin, then you could sort of visualize that there might be up to four different intersection points. Or there could be two, or there could be zero. There's different situations, but four I think is a good expectation here. So, solving. Now, usually I insist on using the substitution method when solving nonlinear systems. But since all of these variables are squared, you can use elimination because you're just eliminating a square variable instead. So for instance, if I add these two equations together, x squared and x squared give me 2x squared, positive y squared and negative y squared cancel out, and I'm left with 8. So 2x squared equals 8. I can continue solving by dividing both sides by 2, which gives me x squared equals 4. And when I take the square root of both sides, it's x equals the plus or minus square root of 4, which is plus or minus 2. So it looks like at this point I have two solutions. All right, and the solutions that I have, one of them has an x value of positive 2, and the other one has an x value of negative 2. So let's take that knowledge and see what the y values are that are associated with each of these. And I can go to either equation. It doesn't matter which one I choose, but I'm going to go with the x squared minus y squared equals 0, because I'm thinking with that 0 in there that the solutions might be easier to find. It's hard to say, really. But let's see, I know the value of x, so I want to solve this for y. So I could say here, x squared equals y squared just by adding y squared to both sides. And then if I take the square root of both sides of this equation, then what happens is I end up with y equals, and again, I have this situation where I'm taking the square root of an unknown, so I have to consider the positive or negative case. So whatever x value I have, the y value is going to be both the positive and negative associated with that. So let me show you what I mean. If x is equal to positive 2, so that's one of the solutions that I've come up with over here, then y is equal to positive or negative 2, which means I have a solution of 2, 2, but also 2, negative 2. So it looks like I'm going to have more than two solutions, because the same thing will happen when I plug in negative 2 as x. So y would be plus or minus negative 2, which uh, if we say the positive of negative 2, that just means, of course, negative 2, and then the negative of negative 2 is positive 2. So you could say, strangely, that this would be technically like minus plus 2. It doesn't really matter. All that matters is you have both the positive and the negative value associated. So when x is negative 2, y can be positive 2 or negative 2. And there are the four solutions to that system.